Give it up for Daniel Kennett.
Thank you. Hello, everybody. My name's Daniel. You may have seen me before. So, a couple of weeks ago, on the Slack, somebody said, we're short for speakers this month. Does anybody have something they can talk about? And I jokingly said, well, there's this thing I'm annoyed about right now. I could give a talk about that. And they were like, yeah, all right. So I'm like, So this is a talk about Swift extensions. And you should listen to me because I have been developing apps on Apple platforms since Xcode was called Project Builder, and it looked like this. You should not listen to me because this is very much an opinion piece. My opinions are quite stupid quite often. They're also wrong fairly often, and more often they're both. So, just a disclaimer. So, extensions are a very nice feature in Swift that are very powerful. And with powerful language features, often comes the problem of it gives you enough rope to hang yourself with problem. This is very common in C++ with templating, if you're aware with that. So I consider extensions enough rope to hang yourself with feature. So, for example, other ones in Swift are like, you can use emoji as symbols. That's super great until you see code like this. And it's like, you can have custom operators and operator overloading. That's super great until you see code like this. And this is great, and you'll write something like this, and you'll feel very clever with yourself. And then a new person will come to the code base, and they'll just, was this? Oh no, sorry. I think I meant to start with the company down the street. I'm sorry. So to just give a little step back, a Swift extension is a way of adding some set of things to a class that has already been declared elsewhere, whether it's in your own code base or in another code base. Swift extensions class extensions are also present in Objective-C. In Objective-C, they're called categories, and they've been around since forever. Protocol extensions are newer. So a protocol extension is a way of attaching code to a protocol. Now, a protocol without extensions is basically a list of methods with no implementation. So being able to attach implementation to a thing that is a thing with no implementation gives a lot of power and is open to quite a lot of abuse. Because protocols in Objective-C are more or less metadata only, the protocol extensions are not a part of Objective-C. So what happened a few years ago is WWDC came around in 2016, I believe, and this talk came out. And then the Swift community saw it, and their minds were just blown. And what happened was protocol-oriented programming. And protocol-oriented programming is the idea that you put protocols first. So the default way of programming is using protocols. Now, this is a valid way of programming, of course, but with all new things, people just took it and ran. So what happened was we had some code like this. We have two very separate objects that have names. And like, well, we should do this as a protocol. Fine so far. But because we can attach code to the protocol, we don't have to have code in the class anymore. So then this happened. So now, because we don't have to have code in the class, we just have this instead. Which is super great, because we did have this. And like, dry means don't repeat yourself. And we are very clearly repeating ourselves here. But here, we're not repeating. I mean, there's 4 times as much code, but we're not. If you ignore the fact that we are repeating ourselves, we're not repeating ourselves anymore. And then what happened is we started to take this, where we'd have a class, a view controller, that conformed to some protocols, and we'd have them in here. And then this happened. And you're probably thinking, what's wrong with this? And on the surface, there's nothing wrong with this. But let's look at what extension actually means. So this is a house. This thing here is an extension. It was added to the house after the house was built. These things here are not extensions. They are windows, which is an unfortunate thing, but because we're on Apple platforms. These were not added after the house was built. They are part of the core house. You wouldn't put a toilet in a house and going, yeah, I'm extending this house. To flip it around and put it back to code, if you think about the word extension and what it means and how they tend to be used, if you remove all of the extensions from a class, its base functionality should still be consistent and operational. So if you have a view controller that has a table view in it, and you took away the thing that implements the table views, this is no longer a table view controller. This is just a view controller that somebody else added table view functionality to. But Daniel, I hear you cry. Table views are a really nice way to organize my code. Look, if you've got a huge view controller, this diff isn't helping. Especially because from here down, you don't have stored properties anymore. You have to, if you have a little function down here and you want to just have a little property that stores some state, nope, that can't be in there anymore. So you need to add a property up here, even though it's miles away from the code that uses it. Not very nice. But Daniel, I disagree. So mark comments are about as much use in code organization as extensions, because extensions aren't really picked up by the open quickly thingamy. And if you have a class that's large enough where just adding these little categories, this is the jump menu. So if you click to this menu to the right of your file name in Xcode, you get a list of all the symbols in the file. And these mark comments appear. So the hyphen makes a divider line, and the text makes an entry in the menu. If adding these mark comments isn't enough, it's probably the symptom of a larger problem. So if you've got a class that's so huge that you have to split it up into extensions, you might want to consider having sub-objects for the functionality, splitting it up into sub-view controllers entirely, and so on. And I've often seen the thing that, small code blocks is easy to understand. But the problem is if you start splitting your code up into small code blocks, when you're adding more code, you'll add more code blocks. And you'll be in a file, and you're like, oh, this other class over here needs more functionality. Well, I'm in this file now, so I'll just add an extension to the top of my file for the other class to add the functionality. And you end up with a class that's implemented over, 10 files? And then if you come into it from somewhere else, it's a huge pain to find out where everything is. So having one block with all of the class, all of the code for a class in it, is not bad. It's very, very, very useful as a new coder, yourself coming back a month later, to be able to open a file, see that, and know, okay, everything I need to know about how this class works and its core functionality is here. I don't need to command click all symbols and trying to figure out where everything is. I've seen code like this. This is a list of numbers. It doesn't need 2 completely separate compilable things. You just, there's no point. Don't make John Travolta sad. It's fine. This is fine. There's no problem. Another thing that I didn't make a slide of is that Swift currently doesn't like you having optional methods in protocols. This is an Objective-C feature that does work in Swift, but Swift doesn't like you doing it. Like, it works perfectly fine. You can have optional function pointers in Swift any way you like, but in protocols, it doesn't like you doing it unless you declare the protocol Objective-C available, and then you can just fine. And the common answer to that is, well, if we have a default implementation that's empty with Swift protocol extensions, they're effectively optional. The problem with this from the other side of this equation as the client of that protocol is you have a list of methods that you have to implement, except some of them have default implementations, so you don't have to implement them. But the code doesn't actually tell you that because there's no metadata to tell you. So basically, you don't implement any, and then you just push the button in Xcode until it stops complaining. And then the ones that aren't there, you can then optionally implement. So that's horrible. So other than me just complaining and not liking to open 20 files to figure out how a class works, there is actually a compile time cost to extensions. So I made a script that generates 10,000 files. No, 1,000 files. 10,000 made my computer go weird. That implements these protocols. So very, very simple protocols. Protocol A, function A. Protocol B, function B. Protocol C, which is A and B, which has that. No default implementations, nothing. So 10,000 classes that are this, but with a different number up here. Took about 12.5 seconds to compile on my computer. Splitting them out into extensions like this, like a very simple way of doing extensions, averaged it up 2%. It's basically insignificant. However, doing it via I forget the name of how this kind of extension by protocol extensions actually increased the compile time by 28%, which is not insignificant. If you have a ton of code like this, where you have really strict things here. Sorry? Constraints, thank you very much. Very strict constraints here, you can really ramp up your compile time. And of course, 1,000 files like this is not common, but it's a 30% increase for the simplest case I could come up with. The Swift language is Swift, but the compiler is not. So you're well, this guy must hate extensions, damn. But no, extensions actually are really good. So there are lots and lots of really wonderful ways to use extensions, and they are a really great addition to the language. So I like to use it for bridging internal and public types. So if you have a type somewhere in your code base that you don't want to leak out to your client, so if you're using some framework in your code that does network requests or whatever, and you want to sort of extend some state out, but you don't want to have your network libraries, implementation details leaked to your app, you can just add extensions to the internal types that convert them. Again, with different unit conversions as well. If you have a coordinate, you can just extend the core location coordinate to support the SWIREF system very simply. It's very nice for little things like that. I also like it because you can add stored properties via an extension if you have any object that is in the Objective-C runtime, which is everything Apple gives you. So any UI kit class, any foundation class, you can use a feature called associated objects to attach properties to an object arbitrarily. So like this, you can make a stored property, and you can make this not any. And that's super nice as well. There's a ton of examples. I'm not, it is a nice feature. Yeah, so that's me just ranting about extensions and stuff. Hope you enjoyed it. Hope you're not too angry. Any questions? Yes. You didn't tell me a story. All right, so I was in a code base, and there was a method, and I was like, okay, this isn't in the class. I just refactored the class, and I haven't seen this at all. And I command-clicked it, and I got to a protocol. And I command-clicked that, and I got to a sub-protocol or something. And it took me 20 minutes to find the implementation of this method. That's basically the story of why I was angry. And I mean, I am guilty of quite a lot of the stuff in here. I have an API that is way too big. It has a protocol, and it's huge. It's too big. And I've split it up into sub-protocols. So the camera protocol is camera live view, camera properties, camera connection. And I've implemented one of the cameras in separate files, one for each sub-protocol, just as an extension, as an extension, as an extension. So all of my stored properties are in the core class as internal, because they can't be private anymore, between files, and then just with underscores, and then there's it's hard. Don't do it. I hate myself more than anybody else, really.